Hey everybody, today we will do another video, and today we will continue doing vectors because I will try to do kind of go through a lot on the theory of vectors because I think you guys will be using vectors a lot. It doesn't matter what kind of engineering you pick, but you will be using a lot of vectors. So yeah. So let's do another example and also another kind of theory. Well, I will say proof of some type of theorem, I guess. So yeah. So basically, it says the following. It says if point 1, right, and I got a coordinate point of x comma y, and then let me just be kind of clear in this, right? So let's say that I have x1 comma y1, and I have a point 2 and 0.2 at x2 comma y2, right? So these are points, right? Are any points, right? So are any point. The vector A was a little like that. Let me just technically has a little thicker or bold A. That's what I'm trying to say. You can make a little bold, right? Vector A in B2 that correspond to P1 right, with a vector like this, P2. Okay, so, and I have some stuff here from last time, and I need to clear that. I did not know that I had this stuff here, but I need to clear this. A lot of this stuff, if you don't clear the canvas, it will still be there. Okay, so let me just clear this. Which I should, clear the canvas though, but I never did. This is from last video that I did. I think I did this in Spanish because I usually upload one in English and one in Spanish. But whatever, I need just to clear it. So okay, so now I think we're good. Okay, so now we're here, right? Okay, so okay, so the bottom line is this, right? So they saying that if this is a vector, P1 and P2 is a vector, it's a one vector, then is, I need to activate that, then is the ball A equal to the vector x2 minus x1 comma y2 minus y1, right? And we close that vector. Okay, so that is, right, that the theorem, right? Now they have a little proof here. I don't think it's necessary to go through the proof. But I don't think it's really necessary, but we can do a little quick. What they're saying is saying if the proof, like I said, right now I'm doing this, but eventually I'm not gonna be able, prove everything. I mean, it's not necessary. I am just doing it because this is vectors. It's important for you to kind of understand this, right? Okay, so it says prove, right? And so it says the vector P P1, P2, right? And position vector for the ball A equal to A1 comma A2, right, are illustrated in figure, okay, are illustrated traded in figure 14.14, figure in figure 14 14 14, right? Okay, so what they doing here is the following. So what they doing is they did a little Cartesian plane like this, right? And then they pick a point like this, P1, S1, Y1, right? And they pick it like this, right? And they started something like that, and then out of this point, and then they went like this, right? And then the end of the arrow, they put P2, which is X2, comma, Y2, right? Now, and then they say that at the origin, they went and they did something like this. They did like that. And then they call this capital A. And then they call that A1, comma, A2. And then they call this the origin, whatever, right? Okay, so based on that graph right there, which makes sense because if you look at it, this is the coordinate, right? So this is x1, y1, which makes sense, right? x1, y1, x2, y2, right? Now based on that, what they did is the following. They say that x2, for example, x2 equal to x1 plus A1. See? Where they got the A1 from? Well, they got it from here. See that? So x2 is equal to x2 is equal to x1 plus this A1, right? And then they say n y2 y2 equal to y1 plus a2. So they did that for 1 point, right? So let me just get rid of this. This is not necessary. Okay, so that's it. And then they say solving for a1 and a2. See, if you solving for a1 and a2 in this case, right? Just try it. So x2 equal to x1 plus a1, right? So you move this to the other side when you solve for a, right? So you're subtracting this to this side, right? And then you get what? You get x2 minus x1 is equal to a1, right? The same thing here. You want to solve for this point. You want to solve for a2. So when you solve for a2, you subtract y1 on both sides, right? And you get what? You get y2 minus y1 is equal to a2. See? That's how they got at the point that this is equal to a1 and this is equal to a2, which is a1 comma a2, right? Okay, so that is the little proof that they did, which is not bad. So let's do an example, right? So let's do an example. So now that I have this, I can actually clear the whole thing. Just clear the whole canvas, right? So let's do an example. So let's do, it says, well, they say that after solving for that, right? After solving for a1 and a2, they found out this. They found out that the bold A is equal to x2 minus x1, comma, y2 minus y1. I'm sorry, y1. So like that, right? Okay, and of course these are vectors. These are vectors. So the correct way to do it would be to make those little vector brackets. This almost look like a vector bracket, but so this would be correct way to do it, right? Okay, so that's it. Okay, so what I can do now, do an example. The example says that given point, given the point, P parenthesis minus 2, comma, 3, and Q four, comma, 5. Right? So So it says A, this is what we need to do. All right, so telling us to do something. So A, sketch P, Q, and QP. Okay? And B, find the ball A and the ball A, right? Find vectors, right? Right? N and B remember, this A and B are the ball. That means that these are some type of vectors that we need to find in B2 that correspond to PQ and QP. Okay, so based on that, right? So we have a V. Now we going through C, and we doing, and then we sketching the new vector that we found on part B, right? And then we doing a sketch. The position vector for A and B. Vectors for ball A and ball B, right? Okay, so this is what we're doing now, right? Now, so we know the point that is given to us, right? So we know the point. So we know the point. The point is the points are what? Are P and Q, right? And we know that the P and Q are -3, 3 and +4, 5, right? Okay, so based on that, we can actually use what we learned, right? We can actually subtract the coordinate, right? We can actually subtract the coordinate, right? We can do x2 minus x1 first, y2 minus y1, right? And we will get that position, right? So let's do part A first. But part A said sketch, right? That's part A, right? So we sketching the points, right? So basically this is what we're doing here. So we come here, we will draw a little Cartesian plan. I don't know how straight it's going to be, but I guess it doesn't matter. You can actually use graph paper, and I'm gonna try to play with it until you get this straight. So you can use graph paper. You can actually do this and make this nice and neat. Okay, so here we can actually pick a point, and we know that one point is what? One point is -2, 3, correct? So -2, I go 1, 2, and I go 1, 2, 3, and the first point is going to be around here, right? And from that, I draw a point, right? I draw a point towards the other point, which is where? Is we have that data back here, 4, 5, right? So I do here, what I do is I do 1, 2, 3, 4, and then I do 1, 2, 3, 4, and 5. And actually, what I can do, I go up to approximately right there. And then I connect those points. I connect from here. Right? And I call this point, which is not exactly, but like I said, you can get it in graph paper. You can call this point, 4, 5. And we can call this -2, 3. Right? So -2, 3, right? Okay, so that's how we actually do the sketching part of it. But also, we need to kind of find the other point, right? So now we will sketch that point, after we find the difference, right, between those 2 points. And it's going to be, that is going to be originated from the origin. So let's do this right here. Let's do A, right? Part A, right? Which is going to be what? It's going to be x2 minus x1, comma, y2 minus y1, right? Okay, so let's do that. right? Why not? Okay, so let's do that. What did I do here? I don't need to put this. Okay. So that A is belong, because we're doing part A. It's kind of confusing because, all right. So, and also this should be, you know, everything that you do, it should be, you know, you're dealing with vectors, you should have those little things like that. Okay. Okay, so let's do this. Okay, so now I have 4, right? For x2, right? So A is equal to what? Is equal to 4. X2 is equal to 4 minus, and then a minus 2. Right? And I put a comma on it. And then I have a 5. And then I have a minus 3. Okay? So with that, I get what? I get A, which is equal to vector. That becomes a positive. So therefore, plus that is going to be what? It's going to be 6, positive 6, comma 2. Okay, so that is the first one. Okay, so we did part A. Yes, we did part, well, part of part, sorry. Okay, so that is part of that, right? So that is part of part B. Okay. So basically I'm sketching this, right? From the origin. I'm sketching it from the origin and I'm going like this. I'm going from the origin to approximately, I don't think this is correct. No. I mean, technically it's correct, but I want it, because the scaling in this is hard to do it with this. But I have 1, 2 more, right? Because I have 6. So I gotta go 1, 2. I gotta go 6 up 2. So I go like this. I start at the origin. Oops. Like that, right? And that can be considered that. Actually, should have done a different color, but sorry guys. So let me just do it in a different color so you can actually see it. Okay, so it started from here. Okay. Just like that, right? And this actually is this right here, which is technically that is 6, comma 2, right? Okay, so we got that, right? Now, Now let's do the next part of it. Let's do the reverse, right? Let's do the reverse now. Remember, we're doing the reverse at this point, right? So yeah. So let's do the reverse. Now, how do we do that? Right? Well, it's just this we do. Actually, we did part A, right? We did. Yes, we did part A. Now we'll do part A, B, right? So to do B, we subtracting x1 minus x2, y1 minus y2, right? So we doing B, we doing x1 minus y2, comma, y1 minus y2. Okay, so now we're just doing basically this. It's the same thing, it's just the reverse, right? Usually we do y1 minus y2, s1 minus y2 minus y1, and x2 minus x1. But in this case, they want us to do it this way. Okay, so let's do it. So we know that in this case, going to be B is going to be equal to what? It's going to be equal to minus 2. That's what we had, right? And then I think we have 4. Yes, we had a 4. So we had 4, and then we had what? 3 and 5, right? And then we had 3 minus 5. We close that, right? So now we said, in this case, right, it's going to be minus 6, right? Minus 6. All right, and minus 6. It's just the reverse numbers, right? And then you have comma minus 2. Okay, now you can actually factor out the negative signs and rewrite this as minus oops. So you can rewrite it as 6, comma 2, which is the same thing, right? Or you can leave it like this, whatever you feel comfortable with, because if when you graph it makes more sense doing it that way. For me, it makes better sense doing it this way. Okay, so now let's do another graph. Let's do it. Okay, so now I am going how many units to the left? I am going 1, 2, 3, 4, 5, 6. And I am going how many units to, how many units up? I'm going 1, and 2, right? But also, they want us to sketch. They want us to sketch the vector, right? So we can have to do that too, right? They want us to sketch the vector. So, which starting from here, so we need to do it this way too. 1, 2, 3, 4, 5. Starting from starting from 5, right? So starting from 1, 2, 3, 4, 5, comma 4, 1, 2, 3, 4, about right there. And then we going to that direction, right? So we going, this is the starting point. Now the arrow is going to be where this point right here, oops, is this point. This is going to be the arrow now. See that? Oops. Okay. So we start at that point and we do 1, 2, negative 3. 1, 2, negative 3. So 1, 2, up 3. Around. Around there, right? So we connect those points, right? This is the starting point. And again, this arrow doesn't look the best. So this graph doesn't look the best. But again, you can do this in graph paper, right? Okay, so this point right here is what? Is negative 2, comma 3. All right? And that will be P. And of course, Q here is 4, comma 5. Right? Okay. Now we need to graph this part of it. Let me just change color. I need to graph that. That will be the last step. So that will be the last step. And I believe that will be the last step. Yes, that will be the last step. So here I am doing this, right? So basically, yeah. So I am doing this. So I start from here. I'm going to see this. Technically, this is a part C. There's a couple steps in this problem, but instead of redoing the graph all the time, I am sketching right now V, right? Because I already sketched P and Q, right? Point P and Q. Now I'm sketching the vector, the new vector that I found, which is technically is part C. We're doing part C now. So and it's negative 6, right? We go 1, 2, 3, 4, 5, 6, and we do down 2, right? So here 2, and we sketch it like this. So I guess like that. Maybe down a little bit, maybe around that, right? And then we start from this point, right? Just like that, right? Now this point will be what? This point will be the point that we have on the, they call it capital B for the point, which is -6, comma, -2, right? Okay, so that's how we actually did that example. And so that's it, guys. I hope you learned something out of this video. If you did, just, give me a like, subscribe to the channel, and thank you for watching. Remember, we learned something at the Conservative Engineering Academy. We learn something every day because Jesus is awesome. Jesus is good with us. And that's it, guys. Thank you for watching. And God bless everybody.